In this problem, we'll use Laplace transforms to solve this initial value problem. First, we apply the Laplace transform of the left-hand side. We get s squared times y of s minus s times y of 0 minus y prime of 0. Then the Laplace transform of negative 3y prime is negative 3s y of s plus 3y of 0. Then plus 2y of s equals the Laplace transform of sine of 2t, which is 2 over s squared plus 2 squared. Okay, now the object is to solve for y of s, so let's collect all the y of s's together. S squared minus 3s plus 2 times y of s. Okay, then this part, y of 0 is 0, so that's 0 and that's 0. I have a minus 1 here, so plus 1 equals 2 over s squared plus 4. So y of s is equal, let's do this in two steps, s squared minus 3 of s plus 2 equals negative 1 plus 2 over s squared plus 4. And that's equal to negative s squared minus 4 plus 2 over s squared plus 4. So that y of s is equal to negative s squared minus 2 over s squared plus 4. And we're going to multiply it by s minus 1 times s minus 2, which is what I get when I factor this. Okay, so that is going to be our partial fractions. This is supposed to break up into a over s minus 1 plus b over s minus 2 plus cs plus d over s squared plus 4, because s squared plus 4 is an irreducible quadratic. So we get minus s squared minus 2 is equal to a times s minus 2 times s squared plus 4 plus b times s minus 1 times s squared plus 4 plus cs plus d times s minus 1 times s minus 2. Okay, now let's plug in numbers to make things a little bit easier for ourselves. Plug in s equals 1. We get, on the left-hand side, we get negative 3. If we plug in s equals 1 on the right-hand side, then this goes away and also that goes away because of the s minus 1 terms. All that's left is going to be a times negative 1 times 5. And so that means that a is equal to 3/5. The other obvious number to plug in is s equals 2. If s is equal to 2, then on the left-hand side we have negative 4 minus 2 makes negative 6. If s is equal to 2, then this and that go away because of the s minus 2's. And what's left will be b times 1 times 8, and therefore b will be equal to negative 3/4. Okay, next let's plug in something else. So let's plug in s is equal to 0 next. The reason I'll plug in s is equal to 0 is because that'll make the cs term go away. So if s equals 0, I get negative 2 is equal to a, which we just found to be 3/5, 3/5 times negative 2 times 4, plus b, which we just found to be negative 3/4, times negative 1 times 4, plus cs. Okay, so if s is 0, that goes away. That leaves me with d times negative 1 times negative 2. And so now I have basically a long algebra problem to solve for d, and it works out that d is equal to negative 1/10 doing the algebra. And lastly, just plug in something else that's convenient and we can figure out what c is. So I'll plug in 3. Any other number could have been chosen, but I'll plug in 3. Plugging in 3 into everything, we get negative 11 on the left. On the right, we have a, which is 3/5, times 1 times 13. Then b, we have negative 3/4, times 3 minus 1 is 2. Then 9 plus 4 again is 13, plus 3 times s minus 1/10 times 1 times 2. Sorry, like 3 times c, not 3 times s. 3 times c minus a tenth. And so now we have a pretty long algebra problem to solve for c, and it works out that c is equal to 3/20. And so there are the a, the b, the c, and the d in the partial fraction expansion. So summarizing, we find that y of s is equal to 3/5 over s minus 1 plus negative 3/4 over s minus 2, then plus 3/20 s minus 1/10 over s squared plus 4. Okay, now we just have to rewrite this in a form that's going to be appropriate for finding the inverse transformation. So the first two terms I'm not going to touch. The first bit is going to be 3/20 times s over s squared plus 4. This next bit I'll write as minus, it's 1/10 times 1 over s squared plus 4. But to apply the inverse transformation, I have a 2 squared down here, so I need a 2 here. So I'll multiply top and bottom by 2. So 2 over 20 becomes 1/10. And therefore, the inverse transformation is therefore going to be 3/5 e to the t minus 3/4 e to the 2t plus 3/20 times cosine 2t minus 1/20 times the sine of 2t. And so that is the solution of this differential equation using Laplace transforms.